Hello students, here as we begin with the topic of limits, first of all we have to understand the meaning of this particular phenomenon called as x tends to a. Alright, now let's understand what does this mean. If we consider a real number line where a is some real number, alright, now x is some variable and it is approaching the value a. That means the value of x is coming slowly closer to the number a, right? So x might be here somewhere initially, then it's becoming closer and closer to a. This is what we call as x tends to a. Now as we can easily observe, when we say that x tends to a, x itself can be either less than a or greater than a. So what we have shown here is x less than a, but similarly x can be bigger than a also and it can still come closer to a. So therefore here we have two situations, that is x tending to a when x is less than a, and which is denoted by x, then an arrow, then a, and we write small minus sign on top of a. So it means that x is coming closer to a through the values which are less than a, or in other words x is less than a. Alright. On the other hand, when x is coming closer to a through the values greater than a, we write it as x tends to a plus. Alright. So these are two important terminologies which we must understand carefully before going further. Alright. Now the question of what is the distance between x and a, how close it is, like how small it can become. So that can become as much as small as we may want. Alright, so we are not specifying exactly what that difference between x and a is. Okay, we are just taking x arbitrarily close to a. Okay, now let us move ahead and take one simple example to understand the concept of the limit of a function. So let's understand here that by the word limit we mean it is the limit of some function. Okay, so let us take a simple example of a function. Say f of x is given by x plus 1, right? Now we all are familiar with the notation and the meaning of this function symbol. That is, when I say the function, it is a kind of, you can think of it as a box. X is an input that goes to it, and what comes out is the x plus 1, which is the expression given by the function. Now what we are interested to know is, as you can see here, f of x depends on x, isn't it? So x is called as the independent variable, and what comes out of the function is called as the dependent variable, which we can typically denote by, say, y. Alright, so y depends on x, like this. So therefore it's clear that if I change the x, then obviously there will be some change in the output, that is y. Or in other words, if I change the x, then f of x will also change, isn't it? So now I am interested to know, if x becomes closer and closer to certain number a, then whether f of x also comes closer and closer to certain another number. Alright, if yes, then that is what we call as the limit of the function. Okay, now that was a very loose definition. Let us take one example so that this will be clear. Okay, now here what I am doing is I am going to plot, or rather make a table of x and f of x, and here in this example f of x is given as x plus 1. Alright, and now let's make x closer and closer to 1 through the values less than 1. So therefore I am writing minus sign on top of 1. Okay, so x may be initially 0, then it may increase slightly, say it may become 0.2, then it may become 0.5, 0.9, 0.99 and so on. Now when x is 0, we see that f of x will be 0 plus 1, which is 1. Then when x is 0.2, f of x will be 1.2 and so on. We can calculate the corresponding values of f of x when x becomes closer and closer to 1. Here you can see that x is increasing from 0 and it is coming very much closer to 1. I am not making x exactly 1, so that is a very crucial point. We are not actually making x equal to 1, we are just taking x as close as possible to 1. So if you want one more example, after 0.99, another number which is closer to 1 is 0.999. So for that the function will become 1.999. So here if you observe closely, if x becomes closer to 1, then f of x becomes closer and closer to the value 2, isn't it? So it is very much clear from the table that f of x becomes closer to value 2. Now let us consider the other possibility, that is now we will make x closer to 1 but through the values greater than 1. So now we want to see the behavior of function as x tends to 1 plus. So once again our function is still same, that is x plus 1. Now since x is bigger than 1, let us start off with some value as say 2, and now we will decrease it. So it will become 1.5, 1.1, 1.01, 1.001, 1.0001 and so on. So correspondingly here, if this is the case, then f of x initially is 2 plus 1, that is equal to 3, right? Then when it reduces to 1.5, this will reduce to 2.5 and so on. Like we will go on reducing the values of the function here. So now it is clear that as x tends to 1 through the values upper than 1, the f of x still tends to 2 and it will come closer and closer to 2. So therefore it is now clear that as x tends to 1, f of x tends to the value 2. So therefore this value 2 is called as the limit of the function f of x as x tends to 1. Alright, so therefore we write this particular fact in this manner, that is we write it as limit of function as x tends to 1 is equal to 2. So this is the example which we have taken. So with respect to this particular function, this is what is the meaning of limit, right? Remember that we are just observing the behavior of f of x as the variable x becomes closer to certain real number. Alright, now let us go ahead. So formally existence of a limit means, that is when do we say that a limit exists? So that is when the limit of a function as x tends to a from the left side, that is when x is less than a, if that limit is equal to limit of the same function as x tends to a but from the right hand side. So in that case we say that in general the limit of the function as x tends to a exists and its value is same as the value of the above two limits, which are anyways equal to each other. Alright, so that is what is the existence of limit. Remember that it is not mandatory that the left hand limit is always equal to right hand limit. If it is equal, if both are equal, only then it means that the limit of the function in general exists. So therefore in this case here, if you observe here, there is no need to write plus or minus since both the limits are basically same. Right? Okay, now moving on, let us recap the important points here, that is Here the first limit as shown as limit of f of x as x tends to a minus is called as LHL, that is left hand limit, and the other one, that is limit of f of x as x tends to a plus, is called as RHL, that is right hand limit, as we have already seen. And secondly, limit of a function as x tends to a is not necessarily same as the value of the function at x equal to a. Alright, so the limit of a function as x tends to a is conceptually different than the value of the function at x equal to a. They may be same in some cases or they may not be same, but as a concept those two are different things, right? Now let's move ahead. Now with respect to the limits, we will go through the algebra of limits, that is how do we calculate the limit of sum, difference, product, quotient of two functions and so on. So the first result says that limit of addition or subtraction of two functions f and g as x tends to a is same as the addition or subtraction of their individual limits. Similarly, the second rule says that if we have a limit of a product, then that is equal to product of limits. Third one is very similar, that is related with the division of two functions. So once again here also we do the division of individual limits, and of course while we do the division it should be assumed or it should be given that the denominator limit is not 0. Right? Fourth rule says that if you want to find the limit of a function multiplied by some constant k, okay, which might be a real number, then it is same as k into the limit of that function. So in other words, the k can be taken out of the limit. So within a limit, if you have some constant, a real constant, then that can be taken outside the limit. So that is what this particular rule says. Right. And we have one more rule that is related with the limit of log of a function. So here the fifth rule says that limit of log of a function is equal to log of limit of the function. So that means log and limit can be interchanged, that is log can be taken outside the limit symbol. But here also once again we know that log is defined only of that number which is positive. So therefore when we take log outside, the limit goes inside, so therefore that limit, whatever it is, must be a positive number, only then the log will be defined for that.